Well, let's try graphing using a slope and a coordinate. In this example, given the slope m equals 2 and the point -2 comma -3, find the equation. Let's try this out. So, using the equation y equals mx plus b, keep in mind this is our basic generic equation. And let's try to keep this one always at the top of our page to make it easier to see. We'll try also a table to plot later on. So, notice that in this case we're given that the slope equals 2 and the coordinate -2 comma -3 will be used to find the equation in this case. Notice that the x value is -2 and the y value is -3. So let's plug it into our formula. We're substituting the slope of 2 where the m is, the -3 where the y is, and the -2 where the x is. Notice that's why we have parentheses around there, to imply that it's still multiplying. M next to an x implies multiplication. So parentheses imply multiplication. So multiplying 2 times -2 gives us -4. And let's get rid of the 4, that way we can solve for b. We want to find the b since that's the only thing that's left to find out. So adding the 4 to both sides, doing the opposite, it was subtracting, right? So we're adding. Let's see, -3 plus 4, that gives us a +1. -4 plus 4 cancels out or gives us 0. So all that remains is 1 equals b, or b equals 1, depending on how you see it. There's our intermediate solution. Okay, so let's plug it back into our general formula. Notice that we originally got the slope from the statement. This is part of what was given in the equation or question. So in this case, m equals 2, plug it in where the m is, and that's not going to change any further, or anymore, I should say. And we also got the v-value. The v-value in this case is 1, so we replace the v-value with the 1. Okay, so now we have the y equals 2x plus 1. And this is our final equation. We found the equation. Let's try graphing it now. So for x values, we can plug in -1, 0, and 1. And try to plug it into our equation to find the y values. Okay, so for the first case, let's plug in the -1 when x is -1. So 2 times -1 gives us -2 plus 1. -2 plus 1 gives us 1. So when x is -1, y is -1 for this particular case. Let's go for the next case scenario. When x is 0, plugging in 0 where the x value is. So y equals 2 times the quantity x plus 1, or 2 times 0. 2 times 0, 0. 0 plus 1, 1. So when x is 0, y is 1. Okay, going for the last case scenario that we picked. When x is +1. So plugging in the 1 value where the x is. And now we have 2 times 1. 2 times 1, 2. So now 2 plus 1 gives us 3. Do notice that the slope tells us that we are increasing by 2. So if we start with the first one, we got a y value of -1. If you add 2, -1 plus 2 gives you 1. And 1 plus 2 gives you 3. So there's your pattern there. Your slope tells us how to increase, or how many values, or how much you'll increase in the y value, I should say. So let's plug it back into our table. So there's our table now. When x is -1, y is 1. When x is 0, y is 1. When x is 1, y is 3. Okay, let's start graphing this. So let's take a look at our graph and label at least the x and y axis. And there's our first dot. When x is -1 and y is -1. Do notice, you can use light lines to show the point, but remember, you're going to erase them since you only want the dots for now. Okay, so let's go for the next one. When x is 0, and y is 1. Well, keep in mind, that's what we call the y-intercept because it has an x value of 0. So, our y-intercept. And let's plot it. So there is our y-intercept. It's on the y-axis. We just go up to where y equals 1. Okay, so now let's plot our last point. 1, 3. So going out 1 in the x direction and up 3 gives us at the right location now. Once again, just using light lines, and then we'll get rid of them. There we go. All we need is the dots. Okay, now we want to trace a line through them for a line of best fit or representation of our graph. There it is. Notice the open arrows means our graph keeps going up to the right forever and keeps going down and to the left forever. So there is our final graph. And notice, let's double check that our coordinate that we originally started with, -2, -3, is actually on our plot. That's the blue dot on there. So now that we placed it on here, we've noticed that it is part of our graph. It lies on that particular equation or line.